All right, so in this particular lecture, I want to discuss the different types of mutations we might come across. Specifically, I want to focus on point mutations, these single base substitutions. So I've already got a couple of things up here on the board. Here's my DNA that's going to act as my template strand during transcription. Here is the mature mRNA transcript that I've transcribed off of this DNA. And then during translation, this is the polypeptide sequence I'm going to get from this. And notice that each of these codons results in a distinct amino acid, the thionine, phenylalanine, glycine, and leucine. And then here, I have my stop codon, which is going to result in no amino acid because that's where the release factor comes in and dissociates the translational complex. So what I want to show you is I want to show you the three different types of mutations that we learned about. I want to show you what a silent mutation looks like, where I'm going to alter the RNA that's generated, and then show you if that has any effect on the protein, which it won't. I want to show you a missense mutation, and then I want to show you a nonsense mutation. Okay, so let's go ahead and look, and in each case, I'm going to focus on this right here. This is where my mutation is going to happen. So let's go ahead and start with a silent mutation. So in this silent mutation, I'm going to mutate the template strand right here. And so this T is going to be modified to AC. So it's now AAC instead of AAG. Well, what effect does this have? Well, we still have the same reading frame, but this is going to cause this to now be UUG. So the question then is, what amino acid is encoded by this codon compared to the one that was originally there? And if you look at the codon table, what you'll find is that UUG still gives us the exact same amino acid. It gives us leucine. And so the reason this is called a silent mutation is because if you only looked at the protein sequence, the sequence of amino acids, you would have no idea that a mutation had occurred, because we still get the exact same thing that we had with our original sequence. So that's why this is considered to be a silent mutation. With silent mutations, the mutation still happens in the DNA and the RNA, but we do not observe that mutation when it comes time to look at the protein and the amino acid sequence of that protein. So that's a silent mutation. All right. So let me go ahead and rewrite my sequence real quick. Alright, so still encoding leucine. Now, let's look at a missense. So we looked at a silent mutation, no change to the amino acid sequence. Okay, so here, now, let's go ahead and again we're going to mutate this thymine. So we're going to mutate this thymine to a guanine. So we're going to mutate this thymine to a guanine, which is going to then mutate our RNA to have the sequence here, UUC. Again, we're still in the same reading frame, each of these codons, but what you'll find is that now this codon encodes not leucine, but phenylalanine. So a missense mutation is a mutation where that base pair substitution results in the change of amino acid sequence. So notice we switched leucine for phenylalanine. So this is a missense mutation. So again, a silent mutation, there's no change to the protein in terms of the amino acid sequence, even though the mutation happens in the DNA and the RNA. In a missense mutation, we see a change to the amino acid structure and the primary sequence or structure of the polypeptide. So now, for the final one, let's see what happens with the final type of mutation. So again, I'm going to just fill this back in. And let's go ahead and do leucine. Okay, so the final type of mutation is commonly called a nonsense mutation. What happens in a nonsense mutation is instead of getting the same amino acid, instead of getting a different amino acid, we wind up getting a premature stop codon. And this is going to shorten or truncate our polypeptide. So let's look at what happens when that happens here. So rather than focusing on the T in this one, I'm going to have the mutation occur here. And this adenine is now going to be mutated to a thymine. What that's going to do is that's now going to convert our mRNA sequence to UAA, which you'll remember, U R away is a stop codon. So now, instead of getting methionine, phenylalanine, glycine, leucine, this is not going to have any amino acid associated with it. So a nonsense mutation is a mutation where instead of getting the same amino acid or a different amino acid, we wind up getting a premature stop codon that truncates our polypeptide. So again, the three types of mutations that arise as a result of one of these base pair substitutions are missense, nonsense, and silent. With silent, there's no change to the amino acid structure, even though there's a mutation in the DNA and the RNA. With missense, there is a mutation in both the DNA and RNA, and we see a change to the amino acid sequence. At least one amino acid changes. And then with a nonsense mutation, there's a mutation in the DNA and in the RNA, and that results in a premature stop codon. So that's what you need to know about these mutations.